And today's topic that I'm going to cover is a transmission system which is used in the industrial robots. This is an overview of this presentation. The presentation is starting with the introduction by comparing with the human skeleton and capabilities with the industrial robots. Second is the type of robotic system used in the industries. And third, the term degrees of freedom and how the degrees of freedom is determined from the robotic system. Fourth, the overview of the skeleton of the powertrains used in the industrial robot systems. Then fifth, the planetary gear arrangement used in the robotic actuators. Sixth, the harmonic drive system which is used in the robotic actuators. Then seventh, cyclonic drive system which is used in the again robotics actuators. And last topics, the factors which has to be considered for selecting such actuators for the industrial robots. And one more topic is that what are the present research is going on this industrial robotics drives. That is also included last, only one slide. Starting with the intro, okay, the robotic systems are compared with the human hand. You can able to see the human hand are made of joints and links. Joints means such as shoulders, elbows, and wrists, whereas a link means it is made up of bones, human hand. So by using it, a human can do works within the human limitation. Here, the term human limitation means an average human can lift a weight equal to its 70 to 80% of his own weight, and that is not applicable for the weightlifter. Okay, I'm saying an average human. So the same skeleton or underlying structures will be used for the robotics system also. Only thing is joints and bones are replaced by the actuators and the metal rigid links. Okay, as like human hand, you can able to see as like human hand, there is a two set of things. As like human hand, you can able to see this blue color line indicating the link and the red color point is indicating the joint. Similar set of observation you can able to see it from the robotics industrial robotics system also, which is given in this figure as a simple configuration. And finally, the same principle of moving and transferring power will be happening between these both robots and the human hands. And this is a very short intro about the robotic systems. And next we move to the next topic, two types of robots. So first, based on the link arrangement, how the robotics are classified. Okay, so these are the following categories based on the link arrangement. First type is articulated robot, in which links are arranged in a series manner. You can able to see. This is the base. On the base, again that will be connected to one link, and there is a joint. Again, that will be connected to second link and third link. So such that if a link of one robot is connected in a series manner, then that will be called as an articulated robot. And next one is a parallel link robot, in which links are parallel to each other. You can able to see this red color line indicating the direction of the motion. But anyway, you can able to see this one also. This is nothing but the links which is having parallel, which will be arranged in the parallel manner. So the following is the animation. This is given for the articulated robot, and there is a huge potential of using this type of robotic articulated robot in the present industry revolutions. I think most of the industries they are using for assembly units or manufacturing units, welding units. For such units, this kind of articulated robot will be used. And for regarding on the parallel link robot, it is having some limitation actually. Where we need a high speed operation. In such application, this kind of parallel link robots are used. Especially this type of robots are used in the food industries for sorting and selecting the products or any kind of items. So these are the very two types. Okay. So based on the link arrangement, what are the types? Nothing but articulated and parallel link robot. And next one is based on the degrees of freedom available in the robot, okay, available in the motions in the robotic systems. Again, the following categories are classified. The first type is nothing but the Cartesian coordinate system. As a name indicating, it is having only the linear motion. Is possible in this type of uh, Cartesian coordinate robots. So the translation will happen along x and y, and you can able to see these are the arrows which will be indicating on which direction it can be able to move. If one of the translation motion is replaced by a rotational, then the corresponding robotic system type is cylindrical coordinate robot. So you can able to see, so vertical motion is possible, translation motion is possible. Apart from that, the rotation is also possible. One rotation, it was replaced by one rotation. So such kind of robot will be called as a cylindrical coordinate robot. And third one, if two translation motion is replaced by the two angular motions, so the corresponding type will be called as a polar coordinate robot. And clearly you can able to see, so one rotation as well as this oscillation as well as to and fro motions which is happen at the gripper is possible in this type of polar coordinate robot. And fourth, we know already articulated robot, okay, in which all the links are moved angularly, through which the translation motion is also possible, and it can be achieved at the gripper end. Then selective compliance assembly robot arm, it will be called as a SCARA. So fifth type is nothing but the SCARA, and which will give only a selective motion where it has to be achieved. In such applications only, this kind of SCARA robots will be used. You will see at what application it will be used. And finally, this is the sixth type, parallel link robot. Already we see about the what this type in the previous thing itself. Okay, and these are the some small applications where this kind of robots are used. The first one is a cylindrical robot in which electronics panel arrangement, TV panel arrangement, such kind of cylindrical robots are used. And the second one, so one assembly unit, it's a 3D view of an assembly unit in which you can able to see. So this actuators can be able to move up and down and rotation. Apart from that, there will be motion happening at the translation. So this is an example of Cartesian. Then third type. So this is a pick and place robot. So in which you can able to see this here you can able to achieve the to and fro motions, and angular motions also achieved in two axes. So such kind of robots will be used for the pick and place. Then again articulated robot. It can be used for the many industries, assembly units. These are the robots are already used. Then coming to the SCARA. So as like parallel and link robot, this SCARA also it is having some limited application. So it will be able to make the movement in a selective directions only. So as like parallel link robot also, this kind of units will be used for the food industries and electronics industries. Then finally, pick and place, which is happening at the food industries by using the parallel link robot. So these are the 6 categories. So based on the degrees of freedom or axis of motion of the robotic system, so this will be classified into the following category. Now coming to the third one, degrees of freedom. Okay, degrees of freedom. So from our mechanics, we already know about what are the degrees of freedom is available in the mechanisms. Nothing but total in a space, total 6 degrees of freedom is available. Even able to see this is indicating red color indicating back and forward, and yellow color indicating left and right, and blue color indicating up and down. Similarly, the green color indicating the roll angles. Okay, and with respect to this red color line, it can be able to rotate like this. And the yawing is happening with respect to blue color axis, and pitching is happening with respect to this yellow color axis. So now coming to the term, the term DOF is widely used in robotics to define the motion capability of the robotic system. So it means
Johnny sir, we could not able to hear you, sir. Yes, please, dear participants, please wait. Johnny sir, can you hear us?
Yes,
Johnny
sir.
sir, can you?
Sir, can you hear me?
Yeah, we can hear you, sir. Could you please go to backslide, sir?
That last one, sir. Okay.
Yes, sir. Sir, I think we disconnected from this, sir. The third one.
From this.
Next.
Okay.
Yes, sir. Please, sir.
Okay. Sorry for the interruption. So that I will start with the third topic. Okay, nothing but the degrees of freedom of an industrial robot. So the term degrees of freedom is widely used in robotic system, which will define the motion capability of the robotic system. And you can able to see, as per our mechanics, we already studied in the mechanics. So in space, there will be a 6 degrees of freedom are available, and these are the degrees of freedom, which is indicating first degrees of freedom indicating by this red color line. So forward and backward, and the second degrees of freedom indicated by the up and down motion, and third degrees of freedom is indicated by the left and right, yellow color line, and fourth degrees of freedom, which is rolling, which is happening with respect to that red color axis, and fifth is a yawing motion, which is happened with respect to the blue color line. And finally, 6 degrees of freedom is occurring, nothing but the pitch with respect to the yellow color axis. So, as per the definition for the industrial robotics, okay, the number of independent displacement of motion created by the robotic system that will be given as a giving the degrees of freedom of a robot. So it is also simply determined from the number of axes about which the motion is happening in such term or such by using such axis also you can able to determine the degrees of freedom of the industrial robot. Now I'm just giving a what are the axes. This is an articulated robot, and what is the degrees of freedom is determined based on this forthcoming animations. You can able to see if I assume the horizontal in this presentation slide, horizontal axis x and vertical axis is y, and perpendicular to the monitor it will be z. So like that, if you consider, now if I draw an axis, y-axis, with respect to this axis, it can able to make the rotation, and it is compared with the human motion also, waist rotation, which is happening by the human. So this is the first axis, and second axis you can able to see raising the shoulder, which is happened by the human, which can be able to done by the human. Similarly, here also with respect to z-axis, here I can able to see this laser point. So with respect to this axis, it can able to make the angular motions. This is the second axis. Now third axis. So apart from shoulder, the knee, you can able to see the elbow motions. With respect to elbow is a joint. So with respect to elbow, again it's a z-axis. The angular motion is happening at the hand. And this is the third axis. Again, fourth axis, the rotation. Okay, or not rotation, the angular motion is happening along the wrist rotation. This is nothing but the fourth axis. So with respect to x-axis, the rotation is happening. Now, fifth axis, the bending motion, which is happening on the wrist. So, with respect to again z-axis, the bending motions, okay, the oscillating motion is happening on the wrist. Then finally, the rotation, you can able to see. If I focus it very, if I focus it, you can able to see. Okay, so here a tumbler is happening at the fingertip of a human. So rotating the finger, rotating the tumbler. Okay, so that same motion is happening on the gripper side also. So total 6 axes are there, and since 6 axes are there, this articulated type of robot will be called as having the degrees of freedom 6. Next, coming to the powertrains. Okay, so what are the powertrains? Now I'm just showing again the articulated robot video. Please look into it carefully, and the corresponding exploded view of such articulated robot, in which first I start with the how many links are there. So here you can able to see this black color link, nothing but the fixer link, which is I am naming as a 1. Next, this is the second link. Okay, then this second link will be connected to the black color link or fixer link, and based on the vertical axis, rotation will be happening on the second link, the turning motion. Again, this is the third link. Third link is connected to the second link, and by the bearing arrangement, it is having a turning path. The second and third, it is having a turning path. Similarly, third and fourth, it is having a turning path. Similarly, 4 and 5, then 5 and 6. So total 6 axes are there. I'm just defining how the 6 axis is connected with the link. And if you see in the next thing, these are the parts which is used, exploded. The exploded view of shown in the industrial robots. What are this? This is nothing but the actuators. So all these the green color rounded parts are this is nothing but the actuators. Now what is meant by actuators? You can able to see at the bottom exploded view. So this actuators consist of this is a typical one type of actuators. Okay, in this actuators, what are the parts are available? We'll see one by one. Okay, it consists of a servo motor. Normal motors won't be used for the industrial robotics application because it is having a huge loss. Losses will be there and precision cannot be achieved. So the servo motor will be used, and this servo motor will be connected. This servo motor will be connected. This servo motor will be connected with the previous link or the fixer link. Okay, and next thing is a gearbox. Okay, a separate set of gearbox available for the industrial robots. Then finally the output shaft, which is connected to the next link. So mechanically it will be like bolted by using the bolts and nuts. So by mechanical connection happening between the servo motor gearbox and output shaft. And this output shaft will be connected to the next link to which the motion has to be given. So all these things, servo motor, gearbox and output shaft, this will be called as a actuators. These all things, all three things will be called as actuators. So these actuators play a major role in obtaining the precise motion in the robotics applications. Now, fifth is the planetary gear drive systems, in which you can able to see. So why we are going for the planetary gear arrangement? So as we know, where there is no conventional, the gear ratio cannot be obtained by the conventional planetary arrangement. In such arrangement, we'll go for the planetary gear system or epicyclic gear train systems. So high gear ratio is possible, and it will be in compact when compared to, for example, 1:100 ratio of 1:100 gear ratio has to be obtained. Means if you use a spur gear, it need a very huge size of a spur gear, or if you use a helical gear. But worm gear also it will be like 1:100 ratio, means the size gearbox size will be very high. So in such cases, this kind of planetary gear drive systems will be used. It will be used for making the motion, and this is the planetary gear drive system, which was used very long back during 1996. The 1990s century, 1990s it was used. So it was made of Friedrichshafen AG. Okay, the company which is manufactured such kind of gear train system, which was used during that era. Okay, now in recently, this is the new powertrain system, gear train system, which will be introduced recently, and the corresponding 1/4 view of this corresponding gear train systems and the planetary gear arrangement is shown here. And for getting a clear-cut idea about this one, you can able to see this one video which will be showing how the gear train systems are arranged. This is one prototype thing you can able to see. So servo motors connect to the ring gear. And sun gear will be placed in the center. And these three are the nothing but the planetary gear arrangement. And this servo motors will be connected to the previous link, and this is the gearbox systems, and this is the output shaft. This output shaft will be connected to the next link. Okay, so this is a typical prototype model of this planetary gear drive systems, in which the robotics systems will be used. Okay, and I'm just giving a two set of comparison. Okay, nothing but first is nothing set of Friedrichshafen AG, which is used for very long back and recently used to planetary gear train systems, in which we are going to compare with the six input values. Nothing but first is the transmission ratio, then next is the acceleration to nominal torque, then third is the weight, and fourth is the shape. Okay, and torque to weight ratio, and maximum input speed is needed. Maximum input speed we are supposed to give to activate this one. So first one is a transmission system. By using the first system, which was used very long back during 1996, during 1990s. So what happened? The maximum transmission ratio of 1:76 only can able to achieve for the industrial robotics applications, whereas the present planetary gear systems can able to achieve up to 1:100 ratios. And coming to the acceleration to nominal torque, it is nothing but the previous system, gear train system, planetary gear train system, we can able to achieve, or it can be achieved only 1.4, whereas the present planetary gear drive system can able to achieve up to 1.6. And coming to the weight, you can able to see drastically how much change of weight is happening. So weight is nothing but the previous systems, it's a 6.4, whereas the planetary gear arrangement which is proposed now, we can able to achieve 3.1. Only the 3.1 kg of weight is available for the actuators. And shape, you can able to say diameter, the diameter 160 mm and length is 190 mm for the Friedrichshafen gear train systems, whereas new gear train system, the corresponding shape diameter will be 80 with a length of 168 mm. On torque to weight ratio, how much torque it can produce for lifting the weight per kg of weight, you can able to see 1.41 only it can be able to produce by the previous system, whereas this new gate system can be able to produce 1.58. Then finally, maximum input speed that can be given to this drive system. It means by the servo motor, what is the maximum speed? What is the maximum speed it can be given to the system? Nothing but by the previous system, it can able to use up to the maximum speed of 5,000 only. But whereas the new gate system, it can be able to use up to 7,000 RPM also. Okay. So even though it is compact and high gear ratios obtained by using this planetary gear arrangement, these are the following disadvantages which makes this planetary gear trace. It's not suitable. It allows some limited applications only. Okay, first one is a backlash. So the gear train systems made of invalid teeth or cycloidal teeth, in which invalid teeth means automatically there will be a backlash will be provided. So this backlash will be giving some efficiency decrement. Then second one is the contact lenses. So the sliding friction and rolling friction. Sliding friction is more in gear contacts. So such a sliding friction will create a heat, and that heat, if the heat is produced, means the lubricant has to be provided. Because such kind of industrial robotics, no such lubricants won't be given. So in such cases, heat will be developed. Those heat will be encountered to the decrement of the efficiency. So this is the planetary gear trace systems which is presently used, and what is the advantages and what is the disadvantages of such system. They are presented in this one. Now coming to the second system, drive system, harmonic drive system. Okay, in the harmonic drive system, okay, it consists of three parts. Just see the thing. In the harmonic drive system, it consists of a wave generator, flux spline, and circular spline. So when coming to the wave generator, you can able to see it consists of an elliptical hub and a thin-walled bearing, which will be at the outer surface of the elliptical hub. And since that is elliptical hub, it can able to produce only the elliptical motions, not exact circular motion. Elliptical motion will be created. And the second component is a flexible spline. Okay, so as the name indicating, it's a flexible spline. You can able to see how much it is flexible. Okay, you can able to see here it can be easily flexible, and the outer side of the spline is nothing but made of the gear teeth. Okay, invalid profile were made on the outer side, and this is the final is the circular spline. Okay, in the circular spline, the inside gear teeth. Okay, inside the spline is made of the invalid profile. Now all together, if it is combined, you can able to see the elliptical wave generator is connected to the flexible spline. Since that is a flexible spline, it will accommodate that elliptical hub, and the rotation it is making the elliptical motion is happening on this wave generator and the flexible spline. And again, when it is connected to the circular spline, now we can able to see where it is getting a contact. Okay, it is getting only this two sides is having a contact, and during the rotation, the consequent next portions will be getting contact. Now again, a small prototype model you can able to see here. Okay, how this harmonic drive system are used. So how much by seeing the rotation itself, the input speed rotation and this is the output speed rotation. You can able to see stepper motor connected to the input shaft, and you can able to see this blue color is nothing but the output shaft. Okay, how much drive reduction is happening? Okay, how much speed reduction is happening? Okay, in this harmonic drive systems, you can able to clearly see from this video. Actually, this harmonic drive system is first introduced in the year of 1955 by Musser. This harmonic drive system initially it was made for the lunar rover vehicle, which was used in the Apollo 15. Okay, and it is having the advantages of zero drag class. But what is the main disadvantages of this harmonic drive system? You can able to see the load independent losses. What does it mean by load independent losses? How it is happening? So when the industrial robotics applications means there will be a fluctuation in the speed, as well as there will be a fluctuation in the load will be happening. So due to this one, there will be a load independent losses happening, which will decrease the efficiency of such harmonic drive systems. but even though is far better than the any other drive systems. Again, I'm just making that previous planetary gear arrangement, which was having a better efficiency. The new planetary gear system with the harmonic drive. Again, I'm taking a six set of inputs: the transmission ratio, acceleration to nominal torque value, weight, shape, torque to weight ratio, and maximum input speed. Okay, first we start with the transmission ratio. So I'm just making the comparison for the same transmission ratios. You get planetary gear system 1:100, as well as harmonic gear system, it is 1:100. Then next one is the acceleration to nominal torque value. You can able to drastically, there was a huge value, you can able to see difference, 1.6, around for the 40% of increment, acceleration to nominal torque are observed for the harmonic drive system, 1.6 to 2.3. And you see the weight also from 3.1 to 1.1 kg. So there will be a drastic reduction in the weight is also happening from 3.1 to 1.1. And you see the shape also. You can able to see this the diameter of this corresponding. It will be made a circular, approximately circular shape. That's why it is given diameter into length. So diameter of this new planetary gear system is nothing but diameter 80 and length is 160. But whereas you can able to see this diameter is 107, 107, but whereas the length is 52. So almost half of the it's more than half length reduction is happening due to this harmonic drive systems. Okay, for using, for example, why it is reduced? For example, if you use the planetary gear system, you are supposed to give a thickness, some thickness of the gear to the planetary gears. So what happened, instead of giving that thickness, so this harmonic drives, this thickness is reduced. It is made of the wave generator, no? Wave generator spline. The corresponding spline thickness is very less when compared to the other planetary gear arrangement. That's why the shape is drastically decreased, and that will influence the weight of the corresponding drive system. Then torque to weight ratio, how much torque is needed for lifting 1 kg of weight. You can able to see for new gear system it is only 1.58, but whereas you can able to see almost 80% increment of torque to weight ratio are observed for the harmonic drive. And the maximum input speed also, maximum input speed can be given to this harmonic drive system is nothing but 7,500 rpm. Can able to give up to 7,500 rpm. We can able to give, whereas in the new gate system it can able to only give the 7,000 rpm only. So to overcome this load independent losses, next drive system are introduced, nothing but the cycloidal drive systems. Okay. So what is mean by cycloidal drive system? You can able to see here from this video. And there is an input shaft. So for understanding purpose, the simple animation is shown here. So this cycloidal drive system, it consists of 4 components. One is the input shaft, which is indicating by the green color, and this input shaft is connected to the cycloidal gear. Okay, this input shaft will be connected to the cycloidal gear, and the rotation will be given. The input shaft rotation will be given to the cycloidal gear, and this cycloidal gear will be held in position by using the pin and roller arrangement. And from the cycloidal gear, you can able to see there is a pin is extracted, a pin is projected from the cycloidal gear that will be connected to the output shaft. Okay, so by using these rotations, and the pins are rotating this member, and the output shaft getting the rotation. So this is a simple animation for cycloidal drive systems, but when it is coming to the industrial robots, how it will be? So in the previous system, you saw only one cycloidal gear, but in the industrial robots, to making it to making the balance, there will be 2 cycloidal gear will be used that you can able to see. This one is nothing but the ring gear, then slow speed output shaft, which is having a pin and rollers, and cycloidal disc, then eccentric gear, which will be connected to the cycloidal disc, and finally the high speed shaft is nothing but which is connected to the input. This high speed shaft will be connected to the servo motor, and this slow speed shaft will be connected to the output link. So this cycloidal drive system is first introduced by the Lawrence Brown in the year of 1927, whereas initially it was used for the boats and cranes. And what are the advantages of this one? I told you that load independent losses. So these are the reasons: large loads and impact loads, which will cause the decrement in the efficiency in the previous harmonic drive systems, and that it can easily accommodate by using these cyclone drive systems. But what is the main disadvantages of this one is nothing but backlash will be happening, and it can't able to cope up high input speed. And again, there will be a comparison that's happening between these two, okay, harmonic drive system and cyclonic drive systems, in which you can able to see these are the transmission ratios. Okay, again, the 6 inputs were taken, and transmission ratio, again, I'm comparing the same transmission ratio drive systems, 1 is 100. And what is the acceleration to the nominal torque? So 2.3, it is having the same value, and weight is nothing but a small increment. The weight is happening in the cyclone drive, and shape is also almost, you can able to see, shape is little bit even the lesser due to the inside cyclonal material. Due to that one, it is having a little bit higher weight. But when compared to the harmonic drive, it is having the shape of the cyclone drive system is less. And you see the torque to weight ratio. So 2.63 can able to achieve by the harmonic drive systems, whereas the cyclone drive systems it can able to achieve 2.33 only. And the maximum input speed can be achieved, or maximum input speed can be used on the harmonic drive system is nothing but 7,500 RPM, whereas cyclone drive system we can able to achieve, we can able to use up to 6,500 RPM input speed only. So even though the harmonic drive systems is advantages than cyclone drive systems, in some applications, if you see the industrial applications, so it will vary from place to place. For example, some will be having the impact loads, for example, crushers. So in the crushers, if you use such kind of things, there will be like large impact loads will be happening. So in such cases, you can go for the cyclone drive systems. Okay, then what are the selection factors which will affect, or which we are supposed to consider with selecting the actuators for the industrial robots? Okay, first one is nothing but this selection factors is given from least to very important factors. First one is the efficiency. So even though the efficiency, it means anyway the mechanical system means the efficiency we are supposed to consider. But when compared to the others, the efficiency for the industrial robotics, it's a little bit less knowledge, less vision will be given to the efficiency, but which will be contributed to reduce the overall cost, operation cost. So the efficiency also has to be considered. Next one, speed and precision. So as we know, the robotics thing, so the actuators as well as the other links, which is consist of backlash and friction will be happening. So due to that, at what position the gripper has to go, that will be affected. So the accurate control systems has to be selected based on the applications, as we say during our manufacturing lab itself. For example, if you're using the lathe, so what is the precision you can able to achieve? So what is the precision means? So again, at what products or what components it will be going to use. So based on that, there will be accuracy level will be given. So depends upon the application, this speed and precision has to be selected for the robotics actuators. Then next one is the safety. So almost now collaborative robots are happening now in the Industrial Revolution 4.0. But even though some of the industries they are using the normal robotic systems for the assembly unit, and in such cases, if the proper safety arrangement like fences has to be given, so what is the size that will be occupied by these robotic systems, that also has to be taken care by the safety aspect. Now payload, how much load it has it has to taken off. Okay, so for example, industrial robots can handle a larger payloads, but whereas the collaborative robots, it can able to lift small payloads only when compared to the larger when compared to the industrial robots, but the payload to weight ratio is higher for the copod. Okay, so similarly, based on this application, again the actuators as well as robotic system has to be selected. Then, and second most important thing is compactness. So as I told you that how much it will occupy, for example, industrial robots, how much it will be occupied on the systems, and that will be also having the key features for the going for the industrial areas. So how much industrial areas we need for installing such robotic actuators or robotics applications. So that also will be taken care while selecting this robotic systems. And finally, the weight. Okay, then first foremost important is the weight. Nothing but most important than anything else. The latest collaborative robots manufactured by QCAS and developed by the collaborative with the PLR German is light in weight when compared to the other industrial robots what is available up to now. So these are the factors why you have to supposed to consider while you are selecting your robotic systems. Then apart from that, what are the present research is going on such actuators? Okay, actuators means the actuators consist of servo motor one and gearbox will be connected to the output shaft will be connected to the next link. I'm just telling about the gearbox systems. What are the present research is going on? So first one is a compatible gearbox for from Genesis Robotics. Okay, actually this you can able to clearly see from this one. This is consists of a sun gear and it will be like surrounded by the planetary gear arrangement. And the corresponding lay diagram of such gearboxes shown here. And this, especially this one, is used for the prosthetic hand applications. Okay, all the gears are made up of plastics. So such kind of gearboxes, compatible gearboxes, it's very light in weight, and this gearbox is used for the prosthetic hand application, and still it is under research only. Next, second type of gearboxes, which is under research till date is nothing but the Archimedes drive, in which you can able to clearly see here. So you can able to see sun gear is at the center, but whereas you see at the planetary gear arrangement, instead of the planetary gear arrangement, it was replaced by the rolling contact. So these are the rolling contact. So due to the rolling contact replacement, what will happen? The losses, sliding friction losses happening between the gear arrangement as well as backlash can be avoided by using such cylindric rolling contacts. So this is the second type of gearboxes which is still under research. And third one, bilateral drive. If you see what all the drives what all we saw up to now, so the different efficiency will be occurred while changing the rotation direction. For example, the articulate robot, it has to supposed to move on clockwise also as well as anti-clockwise also. The efficiency during the clockwise may be lower than the anti-clockwise, or in the vice versa also possible. So to keep the same efficiency, this bilateral drive was developed in the recently, in which both side efficiency, both clockwise and anti-clockwise efficiency can be achieved by using this bilateral drive systems. Then finally, okay, this is the again there is a gear train system, planetary gear train system. So you can able to see this is a motor, brushless motor, which will be used at the center of the gearbox itself. So as I told you that previously, there will be like a servo motor will be there, servo motor will be connected to gearbox. But here in this thing, this planetary gear arrangement is having the inbuilt servo motor plus servo motor, and this servo motor will be connected to the sun gear, and this sun gear will be connected to the planetary gear. So again, this is under research. Okay, gear drive unit embedded with the brushless motor. This is still under research, but how much payload and how much torque to weight ratio and how much weight and how much how much transmission ratio it can achieve, all the things is under research only. And finally, this is one video, okay, up to which we achieved in this Industrial 4.0. For giving a glimpse at this video is given here, you can able to see. Okay, so he is a #1 table tennis player all over the world, and this man has to supposed to compete with the robot in the table tennis. So sorry about this audio. It is not the audio is not coming in this presentation. But anyway, so this is the precision what we achieved now, the industrial 4.0 era. But what happened? Whatever the presentation we saw here, it's only the power transmission system. So apart from that, there will be sensors. Okay. Again, programming will be there. The integrated circuits, IC circuits will be there. So such kind of things is not covered in this one, and I hope that will be covered in the forthcoming presentations. So thank you.